Am I audible now? Am I audible now? I think there is a problem with your system. Any problem with others?
No, sir, it's fine.
Yeah. So first paper. Yes, you can start presenting, and the time, as already mentioned, the time is 8 minutes and 4-minute question and answer.
Good afternoon, everyone. My name is Sumit Kakade. Today I will be presenting our paper performance comparison of YOLO algorithms in drone detection.
Can you make the full screen?
So these are the contents of the paper in the presentation. So introduction. So we have recently seen in a few years the rise of drone technology.
Can you
Drones
please
are now present
make full
from
screen?
toys to security threats. So we
Can you make it full screen? Sumit, am I audible? Neither your screen is moving, neither you are audible.
दिखा क्या first page. Sir, I'm not able to do full screen.
You just see, you just check your.
Is it okay, sir?
There is a icon on the full screen in the bottom of your bar. There is a volume setting, and the left of the left of that volume setting button. That is the full screen icon.
Okay, start. Start करो क्या?
Yeah, you can press F5 also. Press F5. Have you pressed F5?
Good afternoon, everyone. Sir, today I will be presenting paper performance comparison of YOLO algorithms in drone detection. This is the content of the presentation. So, introduction. We in recently few years we have seen the rise of drone technologies. The drones are nowadays present from toys to various security threats. So we started to find approaches to detect drone in our airspace. So we finally come to the newest algorithms called YOLO algorithms. YOLO, the form of YOLO is you only look once. So our mission in this paper was to find the ultimate YOLO variant for drone spotting. So in this research, we find various YOLO versions like YOLO V7, YOLO V8, and YOLO V9 to improve detection accuracy and to find which one is best among all these three new variants of YOLO. So in our literature survey, we found there were various techniques used for drone detection like radar, acoustic sensors, deep learning, fast RCNN. It was suitable for detection experiments, while single shot detection offers accuracy, but it was slow. And there were various advantages and disadvantages of YOLO V7, V8, and YOLO V8 and YOLO V9. So we will look into it. The objectives of this paper was to evaluate the YOLO V7, YOLO V8, and YOLO V9 for real-time drone
Your
detection.
screen is not moving.
So we
You are
assess
still in the
various
past.
parameters, performing parameters like precision and recall, F1 square. We analyze the robustness across various intersection of union thresholds. We also look into the impact of data augmentation on drone detection. Uh, the methodology. So the data overview was we combined
Sumit.
two drone data detection data sets which
Sumit.
were of very clean and high quality annotations. There were around 5,063
Sumit, your
images
screen
which
is
were
not
categorized
moving.
into 4,103 training set, 960 images of validation set, and we took additional 50 photos and videos of from external sources for real world applicability as testing. The structure was image labels, data ML. Hello.
Hello, sir. Hello. Am I audible?
Yes.
Sir, actually, he's having a bit of issue. He can't hear you. So I have told him to rejoin. He'll be rejoining within a minute. So I'll present and then he'll speak. Is that okay?
Anything is okay, but I think I am audible to everyone except those who presented.
Yes,
Otherwise,
sir.
there is no audio issue from my side.
Yes, there is no issue by your side. I've told him to rejoin. He'll be rejoining within a minute. It will just take a minute, sir.
The next author is ready. That paper on machine learning based CO2 emission frame forecasting, a predictive modeling approach for sustainable development. Is the author ready? Then we will start with this paper, and later on we will again come back to 595. This with the author Rohit Sethi. Are you there?
Yes, sir. We'll start.
You start. Better. You share your screen.
Yes, sir. 1 second. Hello,
Yes, fine.
can you hear
You
me?
can start.
Okay. Yeah. So good afternoon, one and all. I'm here to present a paper named Machine Learning Based CO2 Emission Forecasting. I'm Kausigan, Ron Shetty, myself, and Aryan Vyas. So firstly, I will introduce our paper to the panel. So as we all know, climate change poses one of the most significant challenges of our time, and understanding the dynamics of carbon dioxide emissions is crucial for effective mitigation strategies. So in this study, we aim to bridge the gap between traditional predictive models and the capabilities of modern machine learning algorithms. By integrating the diverse datasets, employing sophisticated modeling we seek to enhance the accuracy of CO2 emission forecast. Our research not only contributes to the scientific understanding of emissions, but also provides actionable insights for policymakers and stakeholders striving for sustainability. Today, I will walk you through the literature survey, which lays the groundwork of our predictive model, highlighting the evolution of methodologies, the role of machine learning, and the opportunities for future research. Uh, Going through the literature survey of the paper, of our study, allowing us to contextualize our work within the broader landscape of environmental science and data-driven prediction models. In recent years of research projects, we observed a significant transition from traditional statistical approaches such as linear regression and time series analysis to the integration of machine learning algorithms. This evolution this evolution reflects the growing recognition of the limitations of classical models in capturing the complexities of emission patterns. One survey is the pivotal role that machine learning plays in enhancing the accuracy of CO2 emission predictions. Advanced algorithms, including neural networks that ensemble methods, have demonstrated their ability to identify intricate patterns within large datasets, patterns that traditional models often overlook. This capability is crucial in addressing the dynamic nature of CO2 emissions, which are influenced by a multitude of factors. Importantly, our literature review aims to identify gaps in existing knowledge. While there has been a field, we found that many studies still rely heavily on traditional models, which may not fully capture the nonlinear relationships present in CO2 emissions data. By recognizing these gaps, we aim for the development of more advanced and applicable predictive models. So moving to the objective. So the main and the primary objective of the paper is to advance the field of CO2 emission prediction through the application of machine learning, which has been in the mitigation of CO2 emissions, providing a more accurate, comprehensive, and actionable understanding of emissions dynamics to support environmental sustainability, which will facilitate informed decision making for policymakers and stakeholders by integrating advanced data-driven approaches and advanced machine learning techniques such as neural networks, decision trees, and ensemble models to capture the complex and the non-relationship inherent in CO2 emissions data. This will improve prediction accuracy compared to the traditional statistical methods for the dynamic nature of the emission patterns. Now let's delve into the methodology we employed in our research and highlight the novel aspects that set our work apart. Our approach to CO2 emission prediction is built on a comprehensive framework that integrates several key components. The first one, the data collection and pre-processing. We begin by gathering a diverse range of data sets, including environmental parameters, economic indicators, and temporal informations. This dataset allows us to capture the multifaceted. We then perform data processing on this collected data. Next step is the feature selection, which is very important in our research, which recognizes that not all variables contribute equally to the emission predictions. We employed advanced feature selection techniques. This step was crucial in identifying the most significant predictors of CO2 emissions, such as engine size. In case of taking a automobile industries, these predictors were engine size, fuel type, economic activity. By focusing, we enhance the model's efficiency and interpretability. Moving forward, we carried model development in which we utilize a range of machine learning algorithms with a particular emphasis on linear regression as a foundation model. While linear regression is a traditional method, we integrated it within a broader machine learning framework that includes more complex algorithms like decision trees and ensemble models. This hybrid approach allows us to leverage the interpretability of linear regression while benefiting from the predictive power of advanced techniques. We then finally evaluated a model to assess the model.
Good afternoon, everyone. Am I audible?
No, what happened?
So I will be continuing with what Ronit said.
Okay.
Yeah. So continuing with what Ronit said, I will present the results and discussions from our CO2 emission prediction project using machine learning. Specifically, we have used multi-variable linear regression for this project. Our primary goal was to develop a robust predictive model that can accurately forecast CO2 emissions based on various predictive variables and labels. So like the most important step was to prepare our data set, which included variables such as energy consumption, industrial output, transportation statistics, and economic indicators. After pre-processing and feature engineering, we divided the data into training and testing sets to ensure our model's performance could be rigorously evaluated. The most essential part of our process was determining which features had the most significant impact on CO2 emissions. Throughout our analysis, we found that engine size played the biggest role in predicting CO2 emissions, followed by industrial output and energy consumption. This insight is crucial as it guides us on where to focus for our mitigation efforts. So from this diagram, we can see that the correlation between all the features is above 0.75 except smog level. We have also compared our linear regression models performance with traditional CO2 prediction models, but our model outperformed these traditional models due to the features being very limited towards the vehicle's hardware parts. The simplicity and interpretability of our linear regression model combined with effective feature selection proved very advantageous in this context. One of the most noteworthy findings from our project was the uh, critical emission factor. This underscores the importance of focusing on automotive efficiency and innovation as a strategic approach to emission reduction. Additionally, our model highlighted the substantial impact of industrial activities and energy consumption patterns. So moving forward, we plan to deploy our predictive model into a decision support system to assist already existing policymakers and environmental agencies. Future work we will be focusing on refining our model and incorporating more granular data that is more related to day-to-day activities. Despite our success, we did face several challenges. The data quality and availability were quite significant hurdles because the data was collected from Kaggle. In conclusion, our CO2 emission prediction project has demonstrated the effectiveness of using linear regression by this domain. By accurately forecasting emissions and identifying critical contributing factors, we can support informed decision making and drive impactful policy changes that are already aimed at mitigating climate change. These are our references. Thank you for your attention.
Any question? Any question from the audience? Can you just open your slide
Yes, sir.
Share your slide. So in your slides, you have not given the any diagram of the models that you have used.
Yes, sir. We haven't added the architecture diagram in this particular PPT, but it is there in our research paper.
And what about which places data you have taken and from where you have taken those data?
We have taken it from Kaggle.
Mainly, data was collected from Kaggle, and some of the data were also collected from the companies that are open sourcing their data collections, mainly from the automobile industries.
Yeah.
As you are saying that, so data based on which time, which location. So do you know about those? Because the data will vary spatially as well as temporarily, no?
Yes, so data was basically from our country only, and it was timed from the last 5 to 6 years.
So last 5 to 6 years data, and how many sets of how many data you have to train this model? It will be huge.
Yes,
Yeah.
sir. Some of the data we have filtered out to make it easier to fit into a model, and we can practice the best possible, model that will evaluate the performance of it.
So you said, if I remember correctly, you said it's a linear regression model.
No, sir. We have incorporated linear regression as well as it is actually a hybrid model that uses linear regression for some purposes, and some uses feature selection and in some methods.
Yes, sir.
So why you have chosen linear regression method model?
So because some of the features were giving more impact compared to all other features.
Like?
So like engine size and this one, engine size and fuel consumption that are related directly to the particular vehicle, they give more significant impact on our model. That's why choosing linear regression was giving the best results.
I did not understand why the engine size and why other models will not give the same thing like linear regression is giving. Engine size and fuel consumption, obviously, it is directly related to the CO2 emission, the quality of fuel also. So there are
Yes, sir.
multiple factors.
Yeah, some of the parameters had linear relationships between them, and so the linear regression models provided us simplicity for that, and it made us a straightforward approach for comparisons of the foundations, and also it like Aryan said, also provided efficiency compared to the other models because of this relationship that parameters had within them.
So how many parameters, how you fitted into the linear regressions model? How many parameters were there that you actually find out from the linear regression model?
Yes, for
To fit the data?
fitting the parameters, first we carried for the feature selection. That was important to filter out all the important variables. So like you see in this analysis, we used engine size, cylinders, and I can't and the smog level and fuel consumption that automobiles usually have. So these were the main features that contributed mostly to the model accuracy.
Okay. Uh, who is the next one? Next is next word prediction system using NLP. Who will present?
Yes, sir.
Paper ID. Okay. So you have 8 minutes time. Please share your screen and then make it full screen.
Yes. Sir, is my screen visible? Full screen?
Yes.
Yes, sir. So myself, Ritesh Godse from Artificial Intelligence and Data Science Department from Vishwakarma Institute of Information Technology, Pune. So today's our research paper aims to make a hybrid model regarding next word prediction system using natural language processing. My paper ID is 604 and my co-authors are ma'am Ratna Patel ma'am, Miss Vaishnavi Dolas, myself Ritesh Godse, Soham Wagmaya and Aniket Chopde. And today's presentation will be presented by me. So moving on to the next slide, these are the contents of our slide. So as we know, next word prediction has evolved from a basic version of autocorrect system from the mobile, as well as the next email smart compose, what we use in the email, where we get suggestions based on the from recipient and the previous words. Also the coding means in coding where we get autocorrect or auto completion suggestions. For there we can there this next word prediction model has evolved from the autocorrect section to suggesting the new words. So as per introduction, what is actually the next word prediction model? So for our next word prediction model, it is developed to comprehend complexity of language, means it can be English or any other language, and relates its context based on the previous available information or the data set, effective solving the crucial role of prediction of next words in content generation, like where we use Google Docs, where we are writing emails, we get extra suggestions writing it creatively based on the previous context, and also matching the natural language of humans. Why we are implementing this model? Through rigorous testing and review of current state of the art technologies, we have come up with hybrid model which encompasses and integrates LSTM networks, enhancing its accuracy and speed of prediction. Also, how we are going to make it? We have extracted all the important matrices and added them with LSTM networks, means all the important matrices and findings from the current state of the art technologies are clubbed with LSTM networks to provide it as a supporting features to rank the probability of predicted words to provide best probable next word in the system. These are our literature survey. As per this literature survey, from each of the paper, we have summarized it in specific words, specific outcomes, what we need to use and use as a supporting features for our LSTM network. We have summarized here top 5 papers we have used for literature survey. Also, the objectives to research and test all the current, means we have researched and tested all the current state of the architectures to make a hybrid architecture which will be better than the current ones. They and our second objective is to create a content creation accessibility tool where it improves the writing aid and speed of the next word creation. Also, this hybrid model will increase accuracy and contextual relationships using memorizers in the LSTM network. Testing different models with different data sets, also with different writing styles, writing periods, and also the writer specific thinking based on the. And also the last objective was to generalize the natural language processing procedures and understanding how natural language processing uses and is implemented in day-to-day life, also in new generative AI work. So in methodology, here we have implemented like first of all, here as we can see, from the book of The Magic of the Lost Temple by Sudha Mehti, Pride and Prejudice, and Ulysses by James Joyce. Here we have almost 4 lakh words from combined three of the books, and their period ranges from 1700s to 2015. So we have taken a data which comprises of most of the recent times. Also, writing styles from the lower means children level books till the higher level where commentary or everything was added. In first part, we take the raw text like the word is America. So in the first of all, we take each of the word as an individual entity, split it over these spaces and create their individual tokens. After creating the individual tokens, we implement and give each of the token a word integer assigned to it, 1, 2, to identify unique words available in the vocabulary. Then we create a padding sequence where each of the word is clubbed with the continuing sentences, means each sentence is divided over the next sentence line, and then their sequence is captured, means 1, 2, 3. This is a sequence for the sentence number 1. In the second sentence the sequence can be 4, 6, 8, according to the unique numbers given to the words. After that, we have then made the two panels, input and output, where we analyze, means for the first sentence, if our input is 1, means we have started with the word the, then output should be 2, where the word is America, means here it comes 3 and this is fourth one. So yeah, we have means formulated or dissociated it with yeah, input is 1 and output is 2. Then after the word the, we take output as word. Then here we get the sequence as 1, 2, and here the expected output is 3, that is. The word is, we are expecting is word. In the same sequence we have made the matrix.
We have 2
in the
minutes
form.
time.
Yes, sir. This is our architecture methodology, as I explained in the previous slide. This is our architecture drawing. These are results according to the epochs or the cycles of training the model and the losses associated with it, which decreased over time. And according to the data set we used, these are our perplexity and top 5 accuracy, means top 5 words accuracy based on the data sets Pride and Prejudice, Ulysses, the magic of the book. Here we have achieved 94.4% accuracy for the Pride and Prejudice book, 89.51% accuracy due to its complexity, and it's compared to it is more compared to the previous models. And for conclusion, we will conclude as here we have achieved the LST hybrid LST model, which comprises of very effective implementation of contextual information of previous dataset and identifying the new unknown words or untagged words. For future scopes, here we have advanced AI models, model development, where we can use techniques for better performance, model understanding, comprehensive specific industries where healthcare and finance, predictive models where we can predict new words or new outcomes from the previously were given ideas. And these are our top 5 references used for the book. Thank you, sir. Any questions, sir?
Any question from the audience? So how it is related to the conference topic of smart power control and renewable energy?
Sir, smart power control means when we are estimating new power uses, or we need to estimate how much power is we are required for in the next section, as we know that the coal energy we need to produce it in advance, means we need to plan it that how much energy is required, because we cannot store it. For prediction purposes we can use this next word prediction model. The model can be used for prediction rather than just using it for the next word prediction.
Can you go back to your one? There was one graph about loss. What do you mean by loss in the next word prediction? Yeah.
Sir, loss means here, as we see, loss means the incorrect outputs associated with the given input. Means for a single input like if we input the word, then we get many outputs associated with it over a few cycles, over few iterations. Then on which iteration it correctly maps to the output word, it
It
signifies
depends.
it.
It depends on also the characters associated with the word. If the word is having more number of characters, then how much I'm not able to understand how much justify this figure is regarding to, it should be regarding to a specific word, or you are plotting this graph
Yes, sir.
and
Just
you are
yes, sir.
plotting this graph where in the x-axis there is the epoch and in the y-axis there is a value. So this value means what?
Sir, this value represents the
Perplexity.
uh,
So that is perplexity value.
Okay, this perplexity value will depends on the type of words.
no, sir. It will. Yes, ma'am. Please.
Please continue, beta. Please continue.
Yeah. So, sir, this value will be depending upon the outputs we received. For if we got the input as if our estimated in the dataset, we have the output mapped as conference. If it gives is or are as the output words, they are not correctly matched with the output specified in the mapping in the output input matrix. So it will associate itself it to a higher perplexity value, means it is closer to a wrong value predicted, or false positives, it will be associated with the false positive. So it will be getting a higher perplexity value over if when we proceed with higher number of cycles like 40 or 50 approaches, then it will correctly predict that after we have to predict conference is the word associated with it. So then it will lower the perplexity value, that is error value in the predictions.
Okay, thank you. Next one.
Thank you, sir.
Excuse me, sir. I'm extremely sorry, sir. I had this technical situation earlier. My paper ID is 595. Can I present now, sir?
Okay, you solved everything?
Yes, sir.
Okay, so share your screen.
Okay, thank you, sir. Sir, is my screen visible?
Yes, your screen is visible now.
Sir, may I start now?
Yes, but again, it come back to your make it full screen, and while you are speaking, your slide also should move according to with the synchronization of your voice. Okay.
Yes, sir. Sir, may I start now?
Yes, yes. You can start.
Is it full screen?
Yeah, now it is full screen. You have 8 minutes time.
Okay, sir. Good afternoon, everyone. My paper ID is 595. Performance comparison of YOLO algorithms in drone detection. My co-authors are Rakshit, Sujal, and me myself. My name is Sumit Kakade. So I will be presenting this paper. And this is the content table. So introduction. In recent few years, we have seen the rise of drone technologies. Drones are present everywhere from toys to various security threats. So we try to find the best approach to detect a drone. So we come at YOLO algorithms. So YOLO is an algorithm known as you only look once. It is an algorithm which allows to detect object detection. So we compared various versions of YOLO algorithms for drone spotting. So we compare the YOLO V7, YOLO V8, and YOLO V9 to find various uh, their parameters on basis of accuracy for protect critical infrastructure and authorized drones. So we find out that drone detection was possible using various techniques like radar, acoustic sensor, deep learning, fast RCNN, and various possible ways. And we look why YOLO VCN has various conditions like various advantages and disadvantages of using YOLO V7 and YOLO V8, YOLO V9. So our objective was to evaluate the different versions of YOLO at real-time drone detection. We analyzed the robustness of across various IU threats. We also look impact of data augmentations. So our methodology. So we combined two drone detection data set, which were of very high quality annotations. We took around 5,063 images. They were categorized as training data set of 4,103 images and validation set of 960 images, along with which we additionally took 50 photos and videos from external sources for testing. The structure of these directories were like image labels data.yml. For implementation, we used Google Colab with T4 GPUs, and we used various different variant of YOLO V7, YOLO V8, and YOLO V9 for implementation. We also check where their performance like feature architecture enhancement aimed at rapid and precision object detection for YOLO V7. And for YOLO V9, we use medium configuration chosen for its architectural improvements. And for YOLO V9, we used model variant C, selected for its balance between precision and computational efficiency. So we found in resultant discussion, this was the confusion matrix for YOLO V7. This was the confusion matrix for YOLO V8. And for YOLO V9, this is the confusion matrix. From all this comparison, we found that YOLO V9 was the best option for real-time drone identification in practical application. It provides enhanced security measures and effectively reduce possible dangers. And this table here shows the various performance measures of three versions of YOLO. We find that for YOLO V7, the F1 square was score was 0.3935. For YOLO V8, it was 0.865. For YOLO V9, it was 0.916. Similarly, the precision recall MAP 50 and MAP 95 values are shown in this table. So in conclusion, we found out that YOLO V9 was the provided the best balance for optimal. It provides the optimal trade-off between accuracy and completeness in comparison to all its previous versions. And in conclusion, we found when we compare these three versions of YOLO, we monitored and we exposed it to various unfamiliar images, thereby enhancing its ability to analyze and perform effectively. In future scope, we will like to employ synthetic data augmentation to align prediction and actual drone detection, therefore validating like their efficacy for various domains such as surveillance, security, and related applications. These are the references we used, and thank you, everyone. Any questions?
Any question from the audience? No, what are the difference between this all these versions?
Okay, sir. Sir, here we can see so YOLO V7 YOLO V7 is YOLO V7, YOLO V8 and YOLO V9. In this order, they have various difference like in YOLO V9 it was enhanced for precision and speed. It has Glean architecture and PGI. So what are these Glean architecture and PGI? So I will so the
So
PGI
see,
means
hold on.
yes, sir.
If I say it is YOLO V1 and if I say it is YOLO V7, then can you tell me the one or two distinct difference between these two algorithms?
Okay, sir. So for sir, let's consider YOLO V9. So
No, I am
the
considering YOLO V1 and 7, not 9.
what, sir?
The first version and the 7th version.
Oh, sir, YOLO the version series started from YOLO V5.
Okay, so the 5th version, okay, whatever. First version, if they are saying first version is V5, then what is the difference between V5 and the V7?
Sir, actually, when we started to compare to study, we took the latest three versions. So we look under YOLO V7, YOLO V8, and YOLO V9.
See, this enhanced precision and all these things are there is no quantity, it is all are qualitative terms. So can you exactly say what do you mean by enhanced precision?
So,
basically,
sir, I can explain about YOLO V9. So, YOLO V9 has PGI and Glean. So, PGI is a programmable gradient information, and Glean means generalized Elian architecture. So, what does this enhancement is? It reduces the model complexity while improving accuracy and inference speed. So, what
So
does the PGI
how?
do is it allows, sir, it allows better information propagation in neural networks, and it makes possible for utilizing deep supervision techniques. And on the other hand, sir, the Glean, so it optimizes the trade-off between parameters, computational complexity, and it allows for flexible use across various devices, sir.
Yes, yeah. If I remember correctly, in one of the slides, you have said that you have 5,000 sets of data, no?
Yes, sir.
Approximately 5,000 sets of data. So these data is basically you are trying to detect the drone.
Yes, sir.
So these data, from where you collected these data?
sir, I can answer
we
that. So basically, there wasn't enough data available in a single data set on Kaggle, and the data had too much of noise. So I personally collected 4,000 images from two separate data sets on Kaggle and then annotated them myself using the label MG available on GitHub.
And these data set,
Yes, sir.
these all are images. These data
Yes,
are
sir.
images.
Yes, sir. All are images.
So images means it has how many spatial component?
It has a drone and a bird. Two components.
Spatial component.
Sir, as in?
See, any position, it is about the location also.
Yes. Yes, it is about the location. So annotation is basically we take the picture and then we highlight the area that is X and Y coordinate of the image, particular image, and then we tell the system that this
No,
particular thing is a drone.
that is why initially spatial I told you, why not jet? How do you a 3D model, how you can make it with XY? Then it's a totally a planar. How do you accurately model without the jet component?
No, sorry, sir. X, Y, and Z, all three. I forgot to
But
say.
you are written here. It's the coordinate XY. If you see the labels, you are written XY, width and height. not breadth.
Yes,
So the
sir.
photos that you have taken is basically only a two-dimensional photos. And photos obviously will be always a two-dimensional thing.
Yes, sir. Sir.
Okay. Thank you. Anyway, next. Next is performance analysis of compensation topologies. For 500-watt wireless power transfer for EV charging. Who will present?
Hello, sir.
Yes. Can you just share your screen
Yes, sir.
and start presenting? You have 8 minutes of time.
Hello, sir.
Please start presenting. Make it full screen first.
Is this visible, sir?
It is visible, but better if you can make it full screen. Press F5.
Okay, sir. Sir, is this visible to full screen?
Not yet. So just left of that, there is an icon. If you press that, it will make it full screen.
Okay, sir.
Have you pressed F5?
Yes, sir.
Vaishnavi, I will share the screen. Just a minute.
Okay, sir.
Sir, is the screen visible now?
Yes, it is visible.
Yes, Vishnu, go ahead.
Okay. A very good afternoon to all of you dignitaries and research scholars present over here. I am Vaishnavi Kumar, a student at Pune University, Maharashtra, India. First of all, I would like to thank my professor, Mr. Deepak Evle sir, for guiding me to the best throughout of my research, and I would also like to express my gratitude towards the organizers and conveners of this conference for providing me the opportunity to present our research work in front of you. The title of my research paper is Performance Analysis of Compensation Topologies for 500-watt Wireless Power Transfer for EV Charging. Here are the contents, that is introduction, methodology, results, future scope, conclusion, and references. In day-to-day life in the market research, there are two types of vehicles, that is petrol vehicles, diesel vehicles, and electric vehicles. But to charge the electric vehicles, there are two types of chargers: portable chargers and wireless chargers. In portable charging system, it needs physical connection between electric vehicle and charging station to charge the vehicles. In wireless power transmission system or charging system, it doesn't need any physical connection to charge the vehicle. In WPT system, for transferring the power, it uses compensation circuit for transferring the power. Using the best compensation topologies, we can achieve high efficiency and maximum power transfer. uh, there are some objectives of this research, which is goal to improve efficiency and maximum power transfer.
These are the general block diagram of IPT system. This IPT system works on the principle of electromagnetic induction. First, we give the supply of primary compensation. Primary compensation flux is induced, and these induced flux are linked with secondary compensation. EMF is induced, but we need to charge the battery in DC energy. Rectifier unit is used to conversion of AC to DC form. Battery we will charge. Classification of general classification of compensation topology. There are two types: basic topology and hybrid topology. In basic topology, series parallel, parallel series, and parallel parallel. In hybrid topology, on the mixture of basic topology. But we will focus on there are two topologies: series and series parallel. These are the mathematical modeling of compensation topology. In series compensation topology, in primary circuit, capacitor are connected in series, and secondary circuit are capacitor in connected in series. We apply the Kirchhoff's voltage law in primary and secondary side of the circuit, and capacitance value will find capacitance C1 is equal to L1 square omega 0, and same manner in series parallel topology, capacitor are connected. First circuit, primary circuit capacitor are connected in series, and secondary circuit capacitor are connected in parallel. By using Kirchhoff's voltage law, capacitance value are derived. C1 is equal to L2 square C2 upon L1 into L2 minus M.
This is the actual result discussion of this project topic. This is component are used in to design the SS compensation topology. For this circuit, we can find out by using the above weak formulas for find out capacitor inductance value. For this SS compensation topology, we can use primary inductance is 5.049 microhenry, secondary inductance is 4.990 microhenry, primary capacitance is 0.694 microfarad and secondary capacitance is 0.702 microfarad. Next. This is the actual designing circuit. This is the actual design circuit in ANSYS Maxwell software. This circuit is designed for find out which circuit is best for comparison of the result. This circuit is design and analysis for compensation circuit for 500 watt wireless power transfer. This circuit is this is the graph. This graph are plot between frequency and efficiency. In this graph, x-axis are represent the frequency and y-axis are represent the efficiency. For two graph are difference. First graph is represent for 15 mm distance. This graph are provide 98% efficiency, and B graph is 25 mm for distance. This graph is represent 85%. This is the SP compensation topology. In this parameter, inductance, capacitance are referred to design the SP compensation topology. For inductance is 0.045 microfarad. This is the series parallel designing for this use for the component of the circuit designing. This is the series parallel compensation topology simulation circuit. In this circuit design in ANSYS Maxwell software, and this circuit are graph between 15 mm distance and 25 mm distance. 50 mm distance, this graph is 97% efficiency, and 25 mm graph is efficiency is 85%. Sorry, 67%. And this is the actual specification of the circuit for design of actual module. For design actual module for 500 watt power, this require input voltage is 120 volt, frequency is 85 kilohertz, and output voltage is 48 volt and 10 ampere current. Next. This is the comparison result of series and series parallel circuit. This comparison table represent the series compensation topology are best as compared to the series parallel topology because of which the efficiency is high.
Also, the WPT system has some advantages. It has safe and reliable because of no physical connection between charging station and electric vehicle. It reduces the risk of electric shock, also increases productivity, mobility, flexibility, and scalability. Next. Also, it has some disadvantages. Uh, it has range restrictions, complexity of circuit, high power loss. It sometimes it gives lower efficiency, energy losses. It contains more cost. Applications which is used WPT system in stationary charging system of electric vehicle, wireless dynamic charging system of electric vehicles, agriculture, mobile chargers, biomedical implant. A WPT system has four fundamental topologies, that is series, parallel series, and parallel topologies. By simulating the series and series parallel topology, we get 98% efficiency in series topology for 15 mm distance. That we can conclude the series topology gives best efficiency for wireless power transfer. These are the reference 6 references which These are the 6 references that we refer for this research.
Don't
Yes,
remove
sir.
the slides until it's totally over.
Yes, yes. Sorry.
Yeah. Any question from the audience? There is no question. So, what are the disadvantages that you have shown here for wireless charging?
Basically, sir, the cost is high and there is a range restriction and the circuit is complex. These are the some disadvantages we found.
Now, why there is a range restriction?
Range restriction means the distance at which at one time charge for, let's say, the time required for getting the charging for particularly the EV battery. So after charging by WPT system, it requires let's say 4 to 5 hours, and for the 4 to 5 hours in the one charge, it will travel the distance only the limited. So that is the range restriction. Fewer kilometers it is going to travel. That means.
Is it the range restriction, or it is the basically if you are talking about the wireless charging, then the charging pad and the battery you are charging, it depends upon that is the restriction, because you are actually transferring the electrical power through magnetic field, and if there is a more air, then obviously there will be more losses. So I think the range restriction that you are saying, it's not about your battery range, it is about the distance between the two bodies.
Coils, yes.
Now my question is that you have calculated this efficiency. So how you are calculating this 97% efficiency?
Basically, sir, we have taken the power output which we have calculated, and whatever the power input we have supplied. So based on the ratio, power output divided by power input, we have calculated the efficiency for the two distances.
If you are making it in simulation, then it should give 100%, because it's all simulation. Why there is a 3% loss, or sorry, 1% loss?
Yes, because sir, the distance is less in this case, so the efficiency is higher. Here the distance is going to increase, so thus the efficiency is also going to drop. But by some means, the research is going on.
My question was not that. My question is that basically, if you are making in simulation, okay, so simulation, if all parameters, because we have used the inductor capacitor or ideal inductor, ideal capacitor. So there is no question of any losses, because it's all simulation.
Yes, but the distance we are changing in the ANSYS. So ultimately, the efficiency is going to drop.
Okay, thank you. Next one.
Yes, sir. Thank you.
This is MPPT for EMS GS UX.
Yes, sir. Am I audible, sir?
Yes, you are audible. Please share your screen for 8 minutes time. Into your paper.
Is it visible, sir? The presentation?
Yes, it is.
The full screen?
Let's start now. Yes, full screen.
Good afternoon, everyone. I'm Shomodi Banerjee. The topic of my presentation is Enhanced MPPT for Permanent Magnet Synchronous Generator Based Variable Speed Wind Energy Conversion System. Adaptive Step Size Perturb and Observed Algorithm with a single current sensor. This is the list of contents that I will follow throughout my presentation. Small-scale wind energy conversion systems offer a very promising solution for rural and urban areas because installing large capacity turbines are not practical due to space and other restrictions in urban areas. This paper proposes an adaptable step size MPPT approach that requires only one current sensor. Unlike the conventional fixed per turbine observed method, where adaptable step size approach here adaptable step size approach dynamically adjusts the perturbation step size. This step size increased when the system is far away from the maximum power point. That means the top point of the hill curve, and it decreases as it gets closer, improving the tracking speed, reducing the oscillations around the maximum power point. There are several benefits of this system like faster convergence, reduced oscillation, improved efficiency, etc. This is the literature survey where different methods has been proposed by different research groups. This is the objective of our this study is to suggest an adaptable step size MPPT algorithm, especially for vertical axis wind turbines where only one current sensor is utilized. By utilizing this load current data, this method can easily track the maximum power point without relying on any of the turbine details. This MPPT system employs a straightforward economical controller rectifier setup along with the DC to DC boost converters for the PMSG based variable speed WECS. MPPT is obtained by modifying the duty cycle of the boost converter, facilitating adjustment in generator speed corresponding to varying wind speed. This is the mathematical model of vertical axis wind turbine. The power output from the turbine is given as half rho A Cp phi cube, where rho is the viscosity of air, normally 1.225 kg per meter cube in 25 degrees centigrade. A is the swept area of the turbine, V is the incoming wind speed, and Cp is the power coefficient. Power coefficient basically is a function of two parameters, lambda and beta. Lambda is the tip speed ratio, which is again a ratio of the product of turbine radius to the turbine speed by the incoming wind speed. Beta is the pitch angle of the turbine. For any generally used vertical axis wind turbines, there is no such pitch control mechanism is there. So normally beta is taken as 0. And from this also we can derive the turbine mechanical torque. And if we need to extract maximum power from the wind turbines, we need to operate the wind turbine at the CP point, maximum CP point. From the literature, we know that the maximum power that we can convert from the available kinetic energy of wind is maximum at 59.3%. This is called the Bates limit. But this practically it relies between 45% to 48%. So to extract maximum power, we need to operate our turbine at CP max. If we need to operate the turbine at CP max, it has a corresponding tip speed ratio that is called the lambda max. So our motto is to operate the turbine at CP containing the CP max and lambda max at the highest level. So this part refers to the MPPT establishment of the wind turbine. Now we have to come to the electrical converter part. Condition for maximum power extraction from the boost converter relies on the maximizing power output and the current output. The DC link power and the voltage can be seen from these formulas. And we know at the hill curve, if we reach the maximum power point of the PV hill curve, the dP/dV becomes 0. So if we derive dP/dV equal to 0, we can get D output current to differentiate to D dash. That also becomes 0. Here D dash means 1 minus D, where D is the boost converter duty cycle. This is the circuit diagram where you can find there is a mathematical modeling of wind turbine has been presented at the top, where beta is given as 0 because, as I already discussed, for vertical axis turbines there is no pitch control mechanism is there. One variable wind speed is applied as a input of the turbine, where turbine is directly coupled with the permanent magnet synchronous generator, which is then connected with the uncontrolled rectifier and boost converter along with a resistive load bank. This is the flowchart complete. Okay, sir. This is the flowchart of the research work, where initial, maximum, and minimum values of the different duty ratios has been described. Load current has been measured. Duty cycle is also there. this duty cycle and load current has been compared with the previous cycle. Now, based on this measurement of the current, one factor, distance factor has been measured, that is called alpha. Alpha is utilized to measure whether what is the situation of this cycle from the last cycle. That means how far it has came from the last cycle. Based on the value of alpha, the variable duty step has been designed, and then the modified duty cycle has been applied to the boost converter. This is the results. From the left figure, we can see it is the input of the wind speed, where it varies from the 6 to 12 meters. Right side figure gives the turbine RPM, rotational speed, not in RPM, it's in radian per second. It varies from 48 volt to 96 volt, and you can see it's very closely follows the MPPT. The left side figure of this image gives the power output from the boost converter, where it ranges from 200 to 1600 watts, and it changes according to the change in the wind speed input. Right side image gives whenever the wind speed changes from 12 meter per second to 10 meter per second, the turbine torque changes immediately along with the change in turbine speed. These two curves gives the output of the boost converter output voltage and current. Voltage varies between 100 to 300 volts, and the current load current varies between 1.8 ampere to 2 amperes, 1.8 amperes to 5 amperes. So this study focuses on MPPT control algorithm using the single current sensor, which reduces the cost, enhance the system robustness. And it's a very straightforward and simple kind of solution for a standalone or roadside vertical axis wind turbine employment. It's very much easier to develop this kind of algorithms using some ARM-based microcontrollers like Raspberry Pi, STM32, and other development boards. So this is the list of references that are followed for this project. Any questions?
Any question from the audience? So why can you just go back to your the slides where you have made this adaptation, how you are making it adapting the algorithm?
That means the flow chart, sir.
And you are saying now you made some alpha magnitude of the factor alpha. What is this? What is this alpha factor?
Alpha is the, sir, mod value of the difference of the last cycle current and the current cycle current. That means whenever we need to operate the system on a hill curve, like for MPPT extraction, in case of wind energy conversion system, the hill curve refers to the P versus V or P versus the generator speed. So there is a hill curve. The highest point is the maximum power point. So current value is the whenever the system finds itself in that space, alpha gives the value between this position. Like in this current session, it is actually ascending towards uphill. So alpha gives me at last point where it was and now where it is. That means how much steps we need to apply on the.
Just one moment. It is the input, the turbine parameter. It is the input parameter data or output parameter. This alpha depends on what?
Alpha depends on output current of the boost converter, sir.
Output current of the boost converter. Okay.
Yes, sir.
If that is the boost converter, so do you know that boost converter output current varies in a one cycle? It varies between what point to what point? Average value. It's a boost converter.
Average. Yes, sir.
So
the average
when
value will depends between the.
Yeah, between the
sir, ripple values, that is the IL max and IL min.
Is it? So the average of the diode current is actually flowing through the, if it's a boost converter, diode average current is flowing through the load. And if you see the diode current, It will not be the inductor ripple current. Okay.
Yes, sir.
So there will be in a cycle itself, there is a change in the load current. So how do you know that the change in the load current is due to the variation in the load, variation due to the switching, or variation due to the turbine speed?
I mean,
Are
sir,
you
you are
getting?
saying
Can you just go back to your circuit diagram where you that MATLAB diagram where the boost converter was there?
Yes,
If
sir.
you see that how the diode current will vary in the during the on time, diode is off.
During on time,
Capacitor
sir,
will
diode is
protect the
off.
load.
Yes, sir.
And when this switch is off, the diode is conducting. So during
Yes,
on
sir.
time in a cycle, the capacitor current is a negative current that is basically equal to your load current.
Equal to load current, sir.
Yes, and then it will go back to the inductor current. So there will be huge difference into the load current.
Yes, sir. Actually, whatever current we are getting in performance in the calculation part, we are taking the average value of that current, not taking the instantaneous value of that current.
Okay, thank you.
Thank you, sir.
Next one. Heartbeat classification using 12-layer architecture.
Yes,
Who will
sir.
present? Yes. Share your screen, make it full, and then start your presentation. You have 8 minutes time.
Am I audible, sir?
Yes, you are audible.
Thank
Make
you,
it
sir.
full screen. It is not yet full screen.
Now, sir?
At least till now it is not.
Now is it okay, sir?
So I don't know. It's still the same thing. It is not yet changed. Although I have seen that you have pressed it, but it is not yet changed. At least it is not visible in my desktop. I don't know about others. Yeah, now it is. Please carry. No, again you have. Yes, please carry on quickly. You have 8 minutes time.
Thank you, sir. Good evening, everyone, respected dignitaries and everyone. I am Gayatri. Today, I'm here to present our research heartbeat classification using 12-layer neural networks on behalf of my team. Here are my contents. Introduction. We all know that heart is the essential organ in our body and it pumps blood to all the organs. And here we have four main sounds of the heart: S1, S2, S3, and S4. S1 and S2 are responsible for the lub-dub sounds, which we all know. And S3 is responsible for psychological and pathological states, where here we are focusing on the abnormality because S3 sound is responsible for the abnormality as it depicts the blood flow between the ventricles in our heart. Literature survey. Here, these are the few papers which we have focused on. The first one is heartbeat sound classification using spectral roll-off. And here the accuracy obtained is 77%. And the methods are spectral roll-off, which is a feature extraction mechanism. And their model was built on logistic regression. But the complexity of the model is high, which we found as a drawback. And automated heartbeat classification and detection of arrhythmia using optimal orthogonal wavelet filter bank. This is the second paper, and their method was KNN classifier. And here the dataset was ECG dataset, and where some of the classes were clean and some of them were unclean. So which we have found that the dataset is imbalanced. And the next one is analysis and classification of heart diseases using machine learning algorithms. They have built two models using random forest and gradient boosted algorithm trees. Their accuracy was 97 and 96% respectively. So we found that those two models can cause overfitting and are time taking for training. Our objective is to find the abnormality in the heart by taking the sound of it. And we know that the treatments for these diseases can involve many transplantation surgeries and a heavy cost. So this method can be useful. Methodology, heart dataset. Our dataset is a combination of normal and abnormal heartbeats. The normal classes are 182 and the abnormal classes are 972. And next we have extracted the audios and sample rates from the Librosa package in Python. Next, we have extracted the descriptive statistics, which are variance, skewness, kurtosis, and power mean. Descriptive statistics can summarize a data set. And there are three main fundamentals of descriptive statistics, which are measures of central tendency, which are a mean, median, mode. And coming to next one, central measures of central variability, which variance and standard distribution comes under, standard deviation comes under this. And the third one is frequency distribution. It represents how frequent an attribute occurs in the data. Next, our model is divided into train and test in the ratio 70:30. Our model our model is based on ANN, artificial neural networks. It can replicate the human brain, and it consists of hidden and output layers, one input layer and 9 hidden layers, and one more output layer is built. In the input layer, our extracted descriptive statistics can be given as input, where the hidden layer computes all the calculations and computations, and output is given in the output layer. The test data is evaluated, the model is evaluated with test data, and performance is calculated like accuracy and loss. If the loss is less than 0.775, the result is accepted, else it is not accepted, and again it will extract the descriptive statistics, and like that our model is built. The novelty of this approach is that the descriptive statistics are very simple and easy to understand and extract also. Coming to the results, here we can easily see the difference in the normal and abnormal heart sounds, as in the skewness of normal heart sound, the maximum value is reached at the frequency of 190 or something, and a minimum is reached at 500 change. And coming to abnormal heart sound, there is no particular value, like it is not ambiguous. And coming to variance, uh, variance is the difference of each observation from the mean. And in normal heart sound, the variance is the high peak value is reached at 190, and in abnormal heart sound it is reached at 15 or something. Kurtosis kurtosis of normal heart sound, we can see that the peak value is reached at 500, like that. And for abnormal one, it is at 160. Coming to power mean, we can see that the peak is received at 200, and in abnormal one, it is reached at 25 or 15. And here, based on the previous approach, like spectral roll-off approach, the accuracy was 79, and it was built on logistic regression model. When we tried with a logistic regression model, we achieved 44% accuracy with raw data. And coming to SMOT, when we tried to balance the data set, like when we increase, like I've mentioned, there are only 182 classes of normal heart sounds. So if we try to match the number of classes, we have done that using SMOT algorithms. We have achieved an accuracy of 0.25, 0.5. When we build the model with ANN network, we have achieved the accuracy 88%. So here we can see that the loss is decreased as the number of epochs increased, and accuracy is increased simultaneously. So conclusion, by using our model, the heartbeat signal, it can be classified into regular or irregular using our method, using descriptive statistics. And descriptive statistics are easily comprehensible and easy to understand. Here we have 4 input nodes for giving all the descriptive statistics we have extracted. And the model is run through 100 epochs. So further, for this model, we can identify the kind of abnormality, like there can be any number of abnormality, and here we are depicting only abnormal or normal. In the future, we can depict the kind of abnormality present. These are our references. Thank you.
Any questions from the audience? So I have a small question. Why specifically 12? Number 12? Is there any specific reason for 12 layers? Why not 13? Why not 11?
Yes, sir. When we have built with 12 layers, the accuracy was increased, sir. Like it was acceptable. We can increase the number of layers, but
no, that is the basic question. So if we accuracy will be increased more if you use 13.
It becomes overfitting, sir. Like we cannot obtain, we'll obtain accuracy, but it will result in overfitting, sir.
Is there any metric that by which you are choosing?
Sir?
Is there any metric or any specific reason by which you are choosing these layers, number of layers?
No, sir. Like if we run the model through 12 layers, we have obtained this, but if it was 10 or 9, we would not have been obtained this much accuracy, sir.
Okay, next. Thank you. Next one. Next one is enhancing stock price forecasting.
Yes, sir.
Share your screen, make it full screen. You have 8 minutes time.
Okay, sir. Good evening, everyone. I am Ashrita, representing our research stream from Mallareddy Engineering College for Women. Today, I am going to present our paper titled Enhancing Stock Price Forecasting with LSTM and RF Models Using Risk-Aware Strategies. So next, coming to our contents. These are our contents. And next, introduction. In today's volatile financial market, accurate stock price prediction is crucial yet challenging. Our research aims to address this by leveraging advanced machine learning techniques, specifically long short-term memory and random forest, while incorporating risk management strategies. So actually, what is stock market? It is a financial market where buyers and sellers shares trade shares of publicly held companies. These stock market is volatile in nature because it is affected by economic condition, trading volume, and market sentiment. So traditional forecasting methods often fall short in capturing these intricate relationships. This is where our research comes in. And coming to literature survey, we have studied various research papers in this domain where the researchers have used various machine learning models and analyzed various data sets, which includes Yahoo Finance and Google. So here the researchers have highlighted the significance of integrating traditional financial indicators, which means a statistical calculation based on price and volumes with advanced machine learning techniques to improve prediction efficiency. And they have even used deep learning models like LSTM and convolutional neural network. And our objective is we mainly focused on cryptocurrency, which is Bitcoin currency, which is known for its high volatility. So our data set spans from January 1, 2018 to January 31, 2022, providing a robust foundation for our analysis. Our primary objective is to develop and compare LSTM and RF models and to integrate risk-aware strategies to enhance predicting accuracy and practical applicability. And coming to methodology, first we are going to collect the data. We have collected it from Kharagpur Data Science Hackathon. And in data analysis, we are going to address the missing values and ensure data quality. And then we are going to split the data into train and test. And in data analysis, we are going to apply strategies to the models. The first strategy is trend strategy, which involves analyzing past data to detect emerging trends, whether upward or downward. That means if price is going upward, we have to buy the stocks. If not, we have to sell. The next strategy is mean reversion. In this, price will eventually return to their average. That means if a stock price goes way up, it will probably come back down. And in momentum centric strategy, in this approach, if a stock is moving strongly in one direction, it will continue in that direction for some time. And then we are going to use backtesting strategy, which performs on historical data to know how well our model is performing. In feature engineering, we are going to create new variables or transform existing ones to enhance the predictive power. So in this, we are going to apply risk management strategy to control potential loss and optimize risk reward ratio of our investments. And in model building, we are going to use LSTM, which is long short-term memory, which is used for time series forecasting, as they can capture long-term dependencies and patterns in sequential data. And we also use random forest, which is a machine learning model. It is robust to overfitting and can handle large data sets. And coming to results and discussion, in the first graph, we can see this is the graph which we got when we used LSTM. Here the green line is actual price and red line is model's prediction. By this we can see how well the LSTM is predicting. And coming to second graph, we can see this is the graph which we got in trend strategy. Here the green triangle indicates by buying the stocks, and we can see upward trend eventually. That means we can buy the stocks and we don't have any problem. And next remaining graphs are produced by using the strategies like momentum centric and mean reversion. And in the table, we can see it is a comparative analysis of LSTM and RF. As we can see, we are going to compare these models by using RMSE, that means root mean square error values. Here in LSTM, we can see consistent values. The lower the RMSE value, the superior its prediction. In RF, we can see in testing, we got more value. So we can conclude that LSTM is outperforming the RF. And coming to conclusion, we are going to add the risk aware strategies because to improve our prediction more reliable, and we are going to add some more features features to capture additional market variation in future. And next slide is our references. Thank you.
Any question from the audience? So in this slide, it is not at least it is not visible from my side that it is the share price of it is the price of certain share. This results.
Sir,
any specific share price? Even this results is related to any specific share.
Sir, can you please repeat it again? Your voice is breaking.
My question is that the results that you are showing here.
Yes, sir.
Is it specific to some share?
Sir, in our results, we have used a few strategies, sir, like trend strategy, momentum centric. So we got these graphs based on those strategies.
Based on the strategies, but
yes, sir.
It is basically the share price you are predicting, no?
Yes, sir. Sales price we are predicting, but we are using strategies for that.
But strategy depends on specific share.
Sir, for example, in second graph, we can see it is a trend strategy graph. So by that, we can determine whether to buy or not.
It depends multiple. So that is why I'm asking you. So these all results are not specific to any share. Then how you are getting the data? Data will be obviously specific to some share only.
Sir, we are using this for that specific data only.
The data is related to some share or not? See, say for example, if I want to know the behavior of the Infosys share, then I should have the data of the specific share, no? Otherwise, how do we predict? So
Yes, sir.
Yes.
Yes, sir. For predicting the Infosys, we need to have that. But actually here, for our research, we have taken the sales data set. So we have predicted for the data itself.
What data set? What I did not get your what data set you were talking about?
Bitcoin data set, sir.
Bitcoin data set.
Cryptocurrency Bitcoin data set, sir.
Cryptocurrency data set. That is what I'm asking from the very beginning. So which data set? So cryptocurrency, Bitcoin. So it's only Bitcoin because there is different types of cryptocurrency available. It's not only one. So are you talking about Bitcoin? Am I right?
Yes. Yes, sir.
So that is the question I asked from the beginning. Okay, thank you. Next, last one.
Yes, sir. I'm sharing my screen. Is my screen visible, sir?
Yes, your screen visible. Make it full. I think it's in full screen mode only. No,
Okay.
it is not yet full screen. Is it full screen? Yes. Okay, it is full screen. Okay, you start the presentation and it will be you get 8 minutes to complete it.
Okay, sir. Good evening, everyone, and good morning. Good evening, sir. I am Susovon Bhutani, and I'll be presenting my paper, Microgrid Energy Management, Optimization and Sustainability, with my co-authors Asha Verma and Pankaj Gupta, sir. And these will be the contents of my presentation. I'll be talking about the introduction, literature survey, objective, methodology, result and discussion, conclusion and future scope, and the references. Okay, so microgrid, as we know, is a localized energy system in which there can be different sources of energy. And in this model, we are trying to incorporate renewable sources of energy in this. And our project aims to enhance the utilization of renewable energy and optimize the energy storage within a microgrid system. We focus on minimizing energy costs while maintaining the grid stability and reliability. This presentation will cover our objectives, methodology, and functionalities. Microgrid operation works in two modes, islanded mode and grid connected mode. For our model, we have basically focused on the grid connected mode. With future implementation, it can be modified for islanded mode also. These are some of the few papers we have included in our literature survey, in which control strategies to optimize energy usage in microgrids have been discussed. Some algorithms such as genetic algorithm and particle swarm optimization have been used for the evolutionary optimization. And uh, a paper discusses about the hierarchical control architectures and distributed energy management systems in order to establish grid stability and reliability. The objective was, while creating our model, was to minimize the energy costs by optimizing use of renewable energy. In our model, we have used solar and wind energy. This involves creating balance between different sources to achieve cost efficiency and maximize the utilization of those sources, and maintaining grid stability by ensuring that energy generation, storage, and consumption are balanced, and optimize battery operation to prolong its lifespan considering its efficiency. Efficient battery management is crucial in order to store surplus energy and supply it when the demands are high. We consider peak and off peak hours to know when to charge and discharge the batteries, and certain constraints such as energy balance and capacity constraints of the battery have been considered while making this model. Our methodology started from doing an intensive literature review, and then the key challenges, and then we conceptualized a framework, and then converted into this model. And we have the data have been like, we have dynamic load data, which is a function of sine and cos, and we have implemented in the model. Um, these are the results which we have obtained, in which a renewable energy generation graph we have obtained, and different battery states of charge telling what charge of the battery is available, and on which we can decide whether the source of energy should be from the battery, the sources of renewable, or from the grid itself. And battery operation to efficiently manage the charge and discharge of the battery. Also, the total optimized cost involved in charging the battery, discharging the battery, and using energy from that and from the grid also. And the optimized load profile, in which we have distributed energy to and demand to different sources. Conclusion would be that we have optimized the energy dispatch and maximized the renewable energy utilization. The costs have been reduced as we are prioritizing different sources which are lower in cost at few times, and then ultimately we are using grid when that's the only option left in case of peak hours. And then flexibility and scalability of this model, in which it can be implemented on different platforms to integrate more components to it. Future scope will be multi-objective optimization of this, and like attempt could be made to project this on a hardware, and model validation could be used, in which historical data will also be included. These are our references. Thank you.
Any question from the audience? So in which software you have simulated this microgrid?
In MATLAB we did in MATLAB, we created a programming model.m file. In that, we have done it.
So you have taken two sources. How many sources you have taken?
Sorry?
How many renewable sources you have taken?
Two sources, solar and wind.
What was the power level?
What was the?
Power level. Peak power level of the solar and the wind.
Peak power level of the solar and the wind. I don't actually remember. This graph represents it.
The graph is not visible.
Is the
How
graph
many
not visible?
So small. I don't know how much is the power. So, what are the different kinds of loads you have considered?
Different type of what, sir?
Load.
We have considered only one load function, which we have dynamically generated using a sine and cos function in which a time parameter has been included. We have just used that function, and we have checked it with other data sets because no accurate data set was available. So it approximately predicts the
No, I
variation
did
in
not.
the load.
Hold on. I did not get your point that you have considered some sine and cos for predicting the load. Why?
Sir, we have used a time dependent load function in which we are using time as a factor. It is not a very accurate function of load. It is randomly generated load.
What is the basis for choosing that kind of load?
By combining a time factor with these functions, the load graph load variation was very similar to the variation we see in a regular day life. It was a huge variation in which we could actually see the charging and discharging parameters
And what
accurately.
optimization algorithm you have used?
We have used heuristic in which we have certain ternary operators, and we have used certain decision based making that
No, I did
certain
not get your point. Heuristic algorithm. What do you mean by heuristic algorithm?
in optimization. We have used certain thresholds, and then we have this function related to time in which different based on different grid prices and different load at that time and cost of the grid at that time. We have calculated, we have decided that how much energy to take from renewable and then discharge the battery, and then if an load is not met, we go to the grid.
Okay, so I think so all the 8 papers are presented. There is no more paper. So thank you all for presenting your paper. So anyway, thank you.